I'm Dan Bolanos and I will be talking about our project, which is solar flare classifications. The motivation of our project is to provide amateur astronomers, students, and many others with interactive technology that improves solar flare visualization and classification accuracy. As exposed in our poster, several prior research shows evidence that solar flares can cause damage to astronauts and flight passengers by exposing them to radiation. We have two main data sources. The first one was obtained by scraping NASA's Donkey API dataset for space weather. The second data source is named SHARP, which stands for Sharp Space Weather HMI Active Region Patch. This tracks magnetic concentrations in the sun, and this was obtained by downloading data in Python through the SunPy library. As mentioned, solar flare activity could be harmful and cause several impacts. Many agencies want to anticipate to be able to protect against different areas. This includes radio wave propagation and causing satellite damage. NASA studies have shown that the solar flare activity follows cyclical patterns that repeat every 13 months. During our research, we found and realized that there aren't many interactive nor compelling visualizations tools to trace the space weather activity. NASA's ICE application has 3D visualizations, but doesn't show interactive space weather events such as solar flares. Because of this, our team's innovations visualizations approach uses D3 to show through geolocation data solar flare historical events by using both an equirectangular 2D map and 3D spatial visualizations of the sun. These exciting features will allow you to identify all the solar flare activity in the regions of the sun. Moving on to our data modeling techniques, we train models through a hybrid technique combining long short-term memory neural networks and random forests. As mentioned before, the solar space weather activity follows cyclical patterns. In here, LSTM allows us to use sequences to extract and filter time series behavior from our data, capturing temporal patterns to the solar phenomena. This extracted data then is fed into a random forest classifier to provide classification. Finally, moving on the results, we can find these mentioned metrics to be in the upper bounds, which provides evidence of the good performance of our hybrid models, which shows that LSTM models outperform models that do not use LSTM for a combined accuracy of almost 89%. These results suggest that roughly 9 out of 10 predictions were correct, but we saw evidence that our model struggles a little bit with classifying the minority classes due to the fact that solar flare class 2 dominate the model and contribute to the higher overall accuracy, which aligns to our initial expectations because class 2 flares are the most common of solar activity. I thank you for your attention and invite you to visit our project's website in the comments below. Goodbye.